Alright, so for section 5.1, I'm going to talk about using fundamental identities to simplify trig functions. And here are the trig identities that we want to know. There's a few more in the textbook that if you run across a problem that involves it, you can just look at the list in the textbook. But here are our basic trig identities. So first we have a section that's called the reciprocal identities. And we've already been looking at some of these. So we have that the sine of u is 1 over cosecant u. Cosine of u is 1 over the secant of u. The tangent of u is 1 over cotangent of u. Cotangent of u is 1 over tangent of u. Secant is 1 over secant's 1 over cosine u, and then cosecant of u is 1 over sine of u. Okay. And it should be noted that u can be any value. So it doesn't matter if u is a number, if it's an angle, or just a just a term, an x, whatever. U can be anything, and these are still true. Okay. All right, and then we have the quotient identity. And let's say that the misspelled quotient. Quotient. So we have the quotient identity, and that says that the tangent of u is equal to the sine of u divided by cosine of u. And then cotangent of u is equal to cosine of u divided by sine u. All right. So this is a start on our trig identities. I want to give you a couple more. And they are called the Pythagorean identities. And the Pythagorean identities, one that's common that you probably remember is the sine squared of u plus cosine squared of u is equal to 1. A couple that you may not remember as much is 1 plus the tangent squared of u is equal to the secant squared of u. And then 1 plus cotangent squared u is equal to the cosecant squared u. Alright. So let's do an example of one of these. Let's go with, let's say we have the tangent of theta, cotangent of theta, divided by the secant of theta. Okay? And our goal is to use these identities to be able to simplify this as far as possible. Okay? And the problem with doing these is sometimes it's kind of like solving a puzzle, and there's more than one correct way or more than one possible path to get there. All right, so it may take you a few trial and error situation to figure these out. All right, so I'm going to use, since I have tangent and cotangent and a secant here, I'm going to use this quotient identity. Since tangent is 1 over, or excuse me, tangent is sine of u over cosine of u. Cotangent can be written as cosine of u over sine of u. And it's still all divided by secant. Again, there's already another way that we could have done this, but this is just the way I chose. Okay? Well, as we can see, we have sine of u over cosine of u times cosine of u over sine of u. Well, those just go to 1, right? So it's really 1 over the secant, or well, I should say theta, but it doesn't matter. 1 over the secant of theta. All right. Well, then if I go back to my reciprocal identities, 1 over secant is just equal to cosine. So that trig function simplifies to the cosine of theta. Okay. All right, so that finishes section 5.1. It's just a combination of doing these, using these identities. So we have the Pythagorean identities, we have the reciprocal and quotient identities. You should be able to use those to solve any of these. Like I said, there's a few more on the list in the book if you do need those. You can just look in section 5.1 for that. But if you do have any questions, please feel free to email me. And have a great rest of your day.